All right, let's look at the translation on the s-axis. All right, so if you take the Laplace transform of e to the at f of t, then all you have to do is really find the Laplace transform of f of t, which is capital F of s. And then e to the at part, it's only a translation on the s-axis, basically shifting on the x-axis, and it's shifted to the right by a unit. So a comes from this number constant in front of t. All right, so let's prove it. Proof is pretty simple. So here's a proof. All right, so let's just start with the left-hand side. So Laplace transform of e to the at times f of t. All right, so by definition, this is going to be an integral from 0 to infinity. Then you have e to the negative st. Then you have e to the at f of t dt. All right, then what we can do is we can combine these exponential factors. So we can write it as integral from 0 to infinity. All right, so if you combine that, you're going to have e to the, I'm going to pull out the negative, st. And since you pull out the negative, so it's going to be a negative at, so it's a negative at. All right, so f of t dt. All right, and you can see that the only difference between f of s is you have a negative a here, so this is just a capital F of s minus a. All right. So that verifies this formula here. Also, equivalently, if you want to go backwards, so if you take the inverse Laplace transform of capital F of s minus a, then this is going to be, so you just take the inverse Laplace transform of capital F, so it's a lowercase f of t. Then you can take care of this shifting part by just putting e to the at. All right, so that's that. All right, so let's look at a few examples here. All right, so we already know that Laplace transform of t to the n is n factorial over s to the n plus 1. All right, so what happens if you put e to the at in front? So if you multiply by e to the at, then you have a t to the n, right? Then remember that this is just a simple shifting, so you have n factorial stays the same, but instead of s, we're going to put s minus a, raise it to the n plus 1, right? Same way with the trig one, so if you do Laplace transform of e to the at cosine of kt, then all you have to do is you see s, right? So you have a s minus a instead. And in the denominator, you have s squared, so you have a s minus a quantity squared, but keep everything else the same, right? And you can do the same thing with the sign. So you have a Laplace transform of e to the at sine of kt is equal to, k is the same, but s has to be s minus a squared plus k squared, right? So when you have e to the at in front, all you have to do when you do a Laplace transformation is that find the Laplace transformation of the rest of it and then do the shifting by a units. All right, that's it. I hope that this was clear.